Today we're going to talk about volume and capacity. So the first things we need to discuss is what is volume and what is capacity. So if you take a look at this box, the amount of space that this box takes up would be its volume. And that would encompass how long it is, how wide it is, and how tall it is. If you remember back to our last lesson, when we were doing the volume of a rectangular prism, we were finding the area of the base by finding length times width. And then we were figuring out how tall or how high that prism was, and we were multiplying by the height, and that would give us the volume of the box. And usually we measure volume in centimeters cubed or in meters cubed. So where would you use something like this? Well, for example, if you have a cardboard box and you wanted to know how much space that cardboard box takes up, that would be volume. Also, if you run a shipping company and you have transport trucks, you would want to know how much space is inside the back of your transport truck, so you would know how much stuff you could actually pack into there. So that would be in meters cubed or in centimeters cubed. So how is that different than capacity then? Well, capacity we usually use with liquid. So if we were to open up this rectangular prism and we were to fill it up with water, that would be the capacity of this box. So let's say this box held 1 liter of water or 1,000 milliliters of water. That would be the box's capacity. Usually measured again in milliliters or liters. So they are kind of the same thing, but we don't use them interchangeably. If we're talking about liquids, we would use milliliters and liters. If we're talking about the box in general and how much space it takes up, we would use centimeters cubed and meters cubed. So what kinds of things do we need to remember when we're talking about volume and capacity? Basically, it boils down to this tiny little cube right here, the 1 centimeter cube. So remember, this little cube is 1 by 1 by 1 in all directions. If you could open up this little 1 centimeter cube and take the top off and fill it with water, you would find that this would actually hold 1 milliliter of water. So we could say that these two things are kind of interchangeable. 1 centimeter cubed is the same thing as 1 milliliter of water. So the relationship is 1 centimeter cubed is equal to 1 milliliter. Now this is going to be very, very important because it's the only time that we can switch between volume and capacity, or between capacity and volume. We always have to bring it down to this tiny little cube. It's the only place where we can switch between the two. So what else do we need to know? Well, if you go back to when we were doing metric conversions, we were using king, Henry, died, mother, didn't care much. So we were talking about meters, but we could also substitute liters in there as well, if you remember when we were doing the conversions. So remember when we were talking about meters, we also use centimeters and millimeters and kilometers. When we're talking about liters, mainly it would be liters and milliliters, sometimes kiloliters if you're talking about something very, very large like a swimming pool. But for now, let's just concentrate on liters and milliliters for capacity, and meters cubed and centimeters cubed for volume. So let's say we had an aquarium that looks like, I'm just going to use this box and pretend that it is an aquarium. And let's say that the dimensions of the aquarium were, I'm going to draw it here. "50 centimeters by 30 centimeters. And we'll say that the height is also 30 centimeters. So that's our aquarium. And we want to figure out how much water would fit in there. And we want to figure out actually how much water would fit in liters. So first of all, we need to find out what the volume of this box is. So how much space does this box take up? So if you remember back to the last lesson, volume equals length times width times height. In this case, our length is 50 and our width is 30. So we're trying to find the bottom of the box, the area of the bottom. And then we're going to multiply that by the height of the box, which would give us, well, 50 times 30 is 1,500, and then we multiply that by another 30, and we get 45,000 centimeters cubed. So technically, 45,000 of these little guys would fit inside this aquarium. But I don't want it as a volume. I actually want it as a capacity. So if you remember back to what we were talking about up here, we said that 1 centimeter cubed is the same thing as 1 milliliter. So this is where I can convert them. I know that I have 45,000 centimeters cubed. Well, since they're interchangeable, I know I also have 45,000 milliliters of water that would fit in there. Now the question was asking me how much water fits there in liters, and I'm in milliliters right now. So if I go back to King Henry Died, I'm going from milliliters to liters. 1, 2, 3. Take my imaginary decimal. 1, 2, 3, and there we go. It would be 45 liters of water that you would need to put inside of that aquarium. This also works in the opposite direction. So if I was given, for example, a measurement of liters, let's say I had 60 liters of water and I wanted to know how much volume that would take up. So what size of a box would I need to be able to put that 60 liters of water in? Well, we have to go back to this again. We know that 1 milliliter equals 1 centimeter cubed, but my measurement right here isn't in milliliters, it's in liters. So I need to go back to King Henry died, mother didn't care much. And that's where our L would be as well. So we're going from liters to milliliters. We're moving 1, 2, 3 to the right. So that would give me 60,000 milliliters. And using our conversion here, I know that 1 milliliter is 1 centimeter cubed. So 60,000 milliliters must equal 60,000 centimeters cubed. Okay, so 60,000 centimeters cubed, and maybe the question asks you to convert that into meters cubed. So we want to figure out how many meters cubed this is. Well, remember back when we were doing conversions, if we're starting at we're starting at centimeters cubed, and we're going to meters cubed, it would be 2 jumps. But you have to remember that we're talking about something that's 3D. So we're not just going to do the 2 jumps that we normally would. We actually have to triple that because we're doing 2 jumps for each dimension of this box. So it would be 2 jumps for the length, 2 jumps for the width, and 2 jumps for the height. So we have to triple the number of jumps. So it no longer is 2 jumps, it's now 6 jumps. So we're going to go 1, 2, 3, 4, 5, 6. Our new decimal is going to go there. So when I rewrite it, it's basically going to be 0.06 meters cubed. So 60 liters of water would be 0.6 meters cubed of volume. That's the size of box that I would need to be able to fit this amount of water into. So just always make sure that you're taking your measurements back to 1 centimeter or to centimeters cubed or milliliters. That's really the only place that we can make that conversion. If we took a look at this box right here, the box is 10 by 10 on the bottom, so we would have 100 units along the bottom, and then we would multiply that by 10, so 10 layers. We would have 1,000 of these little squares, and if one of these cubic centimeters holds 1 milliliter of water, then 1,000 centimeters cubed would hold 1,000 milliliters, and 1,000 milliliters is a liter. So we could actually fit 1 liter of water in this container. Again, always going back to how big is this and how much water fits in here, and then working our way around to the other units.